Just wanted to real quick throw together a video on how to graph something that's like this, a rational expression. So there's four pieces we're going to look at. We're going to look at zeros at the top, zeros at the bottom, what happens when x gets really big, and what happens when x equals 0. And those will give us all different pieces of information about our graph. So let's pick off this one first. And this is about extreme behavior. What happens as x gets really large? And x gets really large, the minus 16, the minus 18, don't matter anymore. Like a million squared minus 16 might as well still be a million squared. So as x gets really large, this thing tends towards just that, x squared over 2x squared. I can reduce that to 1/2. So as x gets really big, the outputs of this get closer and closer to 1/2. So that's going to be my horizontal asymptote. Okay, this part here, this is going to give me my y-intercept. When x equals 0, that becomes a 0, that becomes a 0. So what's left is negative 16 over negative 18. And let me think, if I reduce that, that would be 8/9. So I know it goes to the point 0, 8/9, just about 1. So far so good. Next couple of pieces. This part is going to give me the x-intercepts, the zeros. Right, the values that if I plug in an x, the whole thing evaluates to a 0. 0 divided by something. So I'm basically going to try and solve that. I could factor it. It's difference of squares. I could add 16 and square root both sides. Either way, I'm going to factor it. X plus 4 times x minus 4 equals 0. That's a 0. So x is negative 4 or 4. So there's my x-intercepts. It's going to go through the point negative 4, 0, and 4, 0. And then last piece, what can x not be? In other words, I can't divide by 0. These will give me those horizontal asymptotes. So when is this true? So factor out a 2. I can factor that. You could add 18 divided by 2 square root, but I like to factor. Difference of squares. So when x is negative 3 or 3, that's when, if I plug those values in, I'd be dividing by 0, so I can't do that. So let's get up a little bit because I have all these pieces now. Now I can sketch my graph. So let me think about what I have so far. I know x can't be 3 or negative 3, so there's that part. That's supposed to be dotted all the way. Those are just those asymptotes. I know that y eventually gets to 1/2. So I have that one there. I also know it crosses at 0, 8/9. That's almost 1. So that's there. Oh. I'm just labeling everything. I also have some x-intercepts, negative 4 and 4. So it crosses here. Oh, sorry. My son just skipped through. And 4, 0. Okay, so now I have everything. So now what I can do is I can graph this on my graphing calculator. So it's probably hard to see. It's on there though. Yep. So let me graph it. And I get this. Okay, that actually makes sense to me because it's going to have this part in here. So it gets close to that asymptote, touches that, gets back up like that. It should be a little more symmetrical. And then in here, it's going to get close to 1/2 and get close to that asymptote. Same thing here, it's going to go through here, close to that asymptote. So there's a sketch of that graph. So remember, horizontal asymptote, y-intercept, x-intercept, vertical asymptotes, every time.